How to solve simultaneous equations. Two equations that you solve simultaneously at the same time. Two equations with two unknowns is easy to solve. We can think of it as being a big addition. I can work out here that if I was to add the y here with the y here, I would get rid of one of my y's, and that's what I want to do. By either adding or multiplying by 2 and then adding or subtracting together, I will actually get rid of the y here. So if I was to do this, I subtract all of my, I add these two equations together, and I keep all of my x's separately, I keep all of my y's separately, and I keep all of my numbers separately. The only thing I do here is keep the equal sign. So I go from here, x plus 2x equals 3x. Keep my x's under one another. Y plus minus y equals 0. This is what I want to achieve. I want to get rid of either x or y. 2 plus 1 equals 3. So now I've achieved what I want to achieve. I've actually got rid of my y expression totally. So I get that 3x equals 3. Well, now x is easy to solve. Take the 3 to the other side, it becomes a divide, equals 3 divided by 3, which equals 1. So I now know x equals 1. Now I can substitute x equals 1 into my equation number 1. We usually call this equation 1 and equation 2. So substitute x equals 1 into equation 1. What do I get? Then I get that 1 plus y equals 2. Therefore, y must equal 2 minus 1, taking the 1 to the other side and changing the sign, equals 1. So I now know that x equals 1 and y equals 1. Am I finished? No, because the final thing you do to show that you've not made a silly mistake is you substitute x equals 1 and y equals 1 into equation 2. And if you've done it all right, this should balance perfectly. So 2 times x, which we know is 2 times 1, minus y, which we know is 1, equals 1. Is it true? Yeah, 2 minus 1 actually does equal 1, and therefore we've done our simultaneous equation correct. Nice check. Okay, so super. Using this method, you can check everything. Okay, the Swedish way then, how would we do this in the way that the book teaches you? We have two equations, x plus y equals 2. And we first manipulate this expression. We say, okay, we want x's or y's by themselves. So I can say that x equals 2 minus y. I'm just manipulating to get what x equals. X equals 2 minus y. Moving the y to the other side and changing the sign. Then I also have, this was equation 1. I have another equation, number 2, where I say that 2 times x minus y equals 1. Well, I know what x is now, because I've already said that x equals 2 minus y. So wherever I see x, I substitute in 2 minus y. So I write the same equation, but I say 2 times x, which I know is 2 minus y equals 1. Now I multiply my brackets through. 4 minus 2y minus y equals 1. Giving me that 4 minus 3y equals 1. The most sensible thing to do here is to take the y's over to the right hand side to turn them into positives, and the 1 over to the left hand side, so we get 4 minus 1. So if we do that, we get that 3 equals 3y. The 1 goes over here and turns into minus 1. The minus 3y goes over here and turns into plus 3y. So therefore we get y equals 1. When we know that y equals 1, we then substitute that back into this equation here, because we know that x equals 2 minus y, but we know that y equals 1. 2 minus 1 equals 1. So we know that x equals 1 and y equals 1. So this is the Swedish way of fixing simultaneous equations.